I know when I mean, it's like the numbers are slightly improving, but the overall problem is not.
Exactly.
But yeah, I know what you mean. I know what you mean. When I came back to Germany for Christmas, people were complaining about how harsh the measures are. I'm like, no, come to France. You'll see what harsh measures are.
Exactly.
Good morning, Evie.
Hello, everybody.
Hey.
Good morning.
Good morning. Good morning. Long time no see for you as well, Evie.
Yes, maybe soon. Are you going back to the office?
Sporadically.
Sporadically. This is the correct term. Heretically.
Yeah. But kind of on a need to basis.
Okay, so maybe this, I don't know, this week maybe. I will see.
Ooh.
See if it is still here.
I'm still here. Haven't gone anywhere. Right. Who of you has a paper for us other than Valentina, who already shared her link? Love the look on your face. It's okay. You don't have to present. Right. In that case, Valentina, you have as much time as you want today, within an hour. Great. Okay, let's make a start. Welcome to Neuroccino, everyone. Today we have one paper presented by Valentina to us, and the way it works is we, some of us present a paper or a book sometimes, and you get to ask your questions either here on Zoom or over on YouTube, and we try to answer them to the best of our knowledge. Generally, everyone is welcome to present. It doesn't have to come from us. You're welcome to just bring your own paper and present it to us, and we have a chat about it. Right, I think that's all we need to share. Valentina, take it away.
Okay, thank you for the introduction, Steph. This is actually a follow-up paper, follow-up from the discussion we had on cortical restatement in developmental amnesia patients, and in particular, some questions in the session after the paper presentation were on the difference between semantic and episodic memory. And so Stephanie we brought this paper on to my attention, and it's on the varying demands for cognitive control reveals shared neural processes supporting semantic and episodic memory retrieval. So basically, semantic and then episodic memory have been investigated independently all over the literature, mostly independently, because semantic memory refers to the conceptual knowledge that we have of the world. Retrieving the example we gave last time, semantic memory refers to the concept that in concert, we listen to music, whilst episodic memory refers to our memory of the world. So the fact that in a concert 2 weeks ago, we listened to music. Now, I really hope we can go to concert back very soon. And so these two types of memories have been investigated independently, and different cortical and subcortical structures have been related to the retrieval and construction of these two memories. In particular, for semantic memory, it has been linked to the activation of the inferior frontal cortex, posterior medial temporal gyrus, inferior parietal sulcus, and region of the cortical midline, whilst the retrieval of episodic memory has been associated to the activation of posterior medial network, in particular the retrospinal cortex, posterior cingulate cortex, and angular gyri, and medial temporal lobe. However, a few recent studies showed that episodic and semantic memory have some shared cortical structures. In particular, the retrieval of the automatic retrieval of semantic memory has been associated to the activity in the posterior parietal cortex that partially match the retrieval of episodic memories. While the controlled retrieval of semantic information has been linked to the activation of the left inferior frontal gyrus, and this resembles the activity of retrieval of episodic memory traces. So the goal of this study was to investigate whether semantic memory and episodic memory have different cortical substructures that support the retrieval of this memory independently of or taking into account the strategies of recollection of the retrieval of these memories. Or if they have a common base that is associated to the other cognitive functions that are engaged during the retrieval of this memory, and particularly of cognitive control. In fact, other studies that investigated the retrieval of these memories that try to manipulate the load of cognitive control into the retrieval, mainly focused on meta-analysis and over single case studies. So the authors employed functional magnetic resonance to their study objective, and divided the study into experiments. In experiment 1, they collected 46 subjects, and they measured the neural activity during weak versus strong semantic and episodic memories. While to investigate whether there are cortical and subcortical structures that are engaged during both the two long-term memory types during the controlled retrieval of the two memory types. While in experiment 2, the authors investigated the individual difference between the intrinsic connectivity of regions that they found in the experiment 1, so that are shared in the two controlled retrieval of the memories, and to investigate whether they are connected to other structure and cognitive functions. I'm not going to spoil you straight away the results, because I'm going to show you the two experiments. So in experiment 1, participants first they went through fMRI testing for the semantic task, where they are presented with a probe word and both with weak and strong related words that they had to choose. For instance, the probe word was B, and strong related, semantically related words was sting. And then, after this semantic task, fMRI testing, they went through lab training. So outside the fMRI scan, they trained the episodic memory associations, both with a passive and an active approach. So in the passive approach, the participants were shown with pairs of words that are not semantically related, such as apple and flute. And in the active session, participants were asked to combine a probe word, for instance, apple, with the previously shown coupled, so coupled word, so in this case, flute. The authors performed a strong encoding and a weak encoding. In the strong encoding, the active part was presented for 6 repetition, while in the weak encoding, the active part were executed for only 2 repetition in order to match the strong association and weak association of the semantic task. Finally, participants went through an fMRI testing for the episodic memory task that resembled the semantic task testing. So in the fMRI, they were presented with the probe word, and they had to choose the coupled word that they learned in the lab training, both for the strong association, so the strong encoding of the active phase, and the weak association, so the weak encoding of the lab training. The behavioral results show that overall the strong association is easier. So the participant had better performance than the weak association trials. And this is true for both semantic and episodic memory. And then overall, the semantic memory task it's easier, the episodic memory task is easier than the semantic memory ones. Here we have as a score measures the percentage of correct responses, the correct response latency, and then the inverse efficiency score, which is the response latency weighted by incorrect responses. And then the fMRI results show that the activation for the semantic long-term type of memory is pinpoints to the left inferior frontal gyrus, while the activation of the episodic memory over the semantic one show the activation of the bilateral angular gyri and the posterior cingulate and precuneal cortices. While on the, sorry, I have to move you. They made an overlap, so to confirm whether these results are in line with the literature or not. They took the map of activation and fed it to the Neuroccino meta-analysis, and they've seen that the results match the previous literature. Then the comparison of the weak association and the strong association was made for the two types of memory independently, and then a conjunction analysis was performed. And in particular, the conjunction analysis results is more interesting for the purpose of the study. And they've seen that there is a common pattern of structures that are engaged during weak association trials. So when the task is harder, so when the word association trials are harder to perform, and the cortical activation pinpoints to the left inferior frontal gyrus and the anterior insular cortex. And then via a parcellation of a functional parcellation of 7 network, they've seen that these two structures are usually involved in the ventral attentional network, the fault mode network, and frontoparietal attentional network. And these are the results of the first study. I think there is an image also for study 2. No. So the experiment 2 was performed on a different sample of subjects. 140 participants. So it's independent from the experiment 1. And this participant performed resting state functional analysis and a behavioral task that it was similar to the one of the experiment 1, but outside of the scan. So the results of the resting state show that they used as seed regions the left inferior frontal gyrus and then anterior insular cortex, and they've seen that there is they call it anti-correlation with the ventromedial prefrontal cortex. So and then they correlated this lower positive connectivity with the results of the behavioral task, and they've seen that a better performance corresponded to a lower positive connectivity between these two seed regions and the ventromedial prefrontal cortex. Then they taken the maps of this low positive connectivity and fed it to Neuroccino to see how this connectivity to what cognitive functions this connectivity corresponds to or is involved into, and the results show that they are this connectivity is related to is engaged during autobiographical memory, semantic and episodic memory, the default mode, memory retrieval, and also more social abilities such as theory of mind, mentalization, and other more. They selected the first 100 results. Finally, they looked into the intrinsic connectivity of the ventromedial prefrontal cortex, and they've seen that it positively connects with the default mode network, and then the silence ventral attentional network, and the limbic network, and the frontoparietal network. So, take-home message is that both the semantic and episodic memory share similar structure. neural structures, in particular in the retrieval of the two memories, which is the left inferior frontal gyrus and then the anterior insular cortex. The left inferior frontal gyrus has been already shown to be involved into cognitive control, and then probably no. So the results show that the activation of this, so the more the cognitive control, the less activation of the ventromedial prefrontal cortex, and hence of the default mode network, and then other attention associated functions. Thank you.
Thanks, Valentina. Any questions? Leah.
Thanks, Valentina. I was wondering if they share a same structural basis with the episodic and semantic memory. Is there maybe a test that can include both of them? So if a patient have an impairment or a lesion in that area, there is a way of capture the combination of these two abilities, or you just test it separately in a neuropsychological test? Just I was wondering.
Thank you, Leah, for the question. And it's actually the opposite. The issue is the opposite. So it's very difficult to disentangle semantic memory and episodic memory. In fact, the authors include this in the limitation of the study because the semantic memory task may entangle association of words that are strongly related to episodic memory, and it's true also the opposite. So the episodic memory task may entangle words that for someone could be semantically related.
Okay, so they are combined also in reality and in the anatomy.
Yeah.
Thank you.
Michelle, you also had a question.
Sorry, I arrived a little late and I didn't see the design of the experiment, but were the participants supposed to respond like verbally during the scan?
That's a good question. We can have a look at the. I don't think they respond verbally. Experiment 1. I don't see it.
Okay.
The experiment 1 description.
Was the material like verbal?
Yeah, so they see a word, the probe word on the screen, and then 3 choices, and they have to pick the associated word to the probe one.
I see. Yeah, because so like in the literature, you have double dissociation between semantic and episodic memory, which means that they don't overlap, or they don't completely overlap, which is fine with the results here. But because there is a conjunction analysis that is centered on the posterior part of the inferior frontal gyrus and the insula, which is a typical place where you can find some stroke, those strokes are not associated with memory impairment. And so I'm trying to get my head around what balance between
neuropsychology.
Yeah, where do we find a common ground of understanding and bridge a gap between, you know, the clinic and this experimentation in
well,
health.
according to these results, I wouldn't expect a memory impairment because it's more related to cognitive control, because these structure here that are the results of the conjunction analysis, they actually relate to the weak association performance. So words that are hard to associate.
I see.
And hence they need more cognitive control.
I see. I see. All right. Nice work.
Any other questions? No, none at the moment. Well, that would be it for today then, given that this is the only paper we had. Thank you all for coming this morning. Have an exciting week in science, and we shall see you next Monday again. Thank you.